Hello everyone, and today let's solve a Leetcode question, max points on line. So yeah, I have attempted this before back in the day sometime, but let's try it again. I never actually ended up solving the question. So given an array of points where points I is the x and y coordinate, return the maximum number of points that lie on the same straight line. Okay, for here, they're all in the same line. For here, they're all in the same line. This is a computational geometry problem. So basically, we know that any 2 points can form a line between them. Now, for another point to be on that line, then it must have the same slope with the other points. So it must have the same y-intercept formula, so the same y equals mx plus b. So given for each point, we can look at the others and check which ones have a slope that is, how many of them have the same slope to this one point. So if I look at this point right here, I'm going to check all the other points. So this is going to be an O of n squared algorithm. So I'm going to check this point, and then we'll look at this point. This is going to be a slope of infinity to this point. We're going to look at this point, and then this is going to have some slope, whatever we can say. This is something like this is -1 or something, and then we check the rest of the points. This one, we check this one, and we know this has a slope of -1. Actually, this can be whatever. This is a slope of -1. Now we check this point to this point now, and we know this also has a slope of -1. So because it forms a line with this point with the same slope of -1, this means that all 3 points are on the same line. And we repeat the same process for this point, and we find the same result. So let's code this up. We can have res is equal to 1 at first, and we say for I in age at points, and then we'll say for j from I plus 1 to points. We're doing it from I plus 1 because we've already checked. Say we have 1 1, and we start off with 1 1, and we can check all the other points from here, and then we go to 3 2, and then we check all the other points. We don't need to check 1 1 and 3 2 again because it's already been done. So we have to check the rest of the points. We don't need. We can save some time by not counting the duplicates. Same time complexity, but just a little bit of optimization. Now we can have, let's set a counter, and now let's calculate the slope. So given slope is equal, so let's actually do x1, x and y, right? Yeah, x and y. x1, y1 is equal to points I, and x2, y2 is equal to points j. So these are our 2 points that we're looking at. And now the slope, or you say m, is going to be rise over run. So y2 minus y1 divided by x2 minus x1. But we also have to consider the case where x2 and x1 are the same, and then we have a slope of infinity. So let's consider that and say if x2 minus x1 is equal to 0, and we're going to have m be equal to infinity, and then otherwise we're going to have m be our rise over run. Okay, so now we've calculated the slope between the 2 points. So we also want to check if the slope is in counter. If m in counter, we'll say if m is not in counter, then we shall initialize it. Counter m is equal to 0, and then we can just do counter m plus equal 1. So now we've compared one point to all the other points and gotten the slopes and how many points have that corresponding, the same slope to that point. Meaning that we can just do, we want the max value in counter, so let's find that 4 m in counter we are going to do res is equal to the max of res and counter at that slope. So what we started our result off at 1 because we know we're always going to have 1 point minimum on the line. Now we're checking all the slopes and the corresponding and how many points have the same slope compared to the point we're checking. And then we compare that with our current result and get the max because we want the max points on the line. Now let's try and return res of this. Oh, yeah, counter should go here, run this again. And this is wrong. Oh, okay, so this should, how many are on the slope? It's counter plus 1 because we are gonna include the current point that we're looking at. Makes sense? Let's submit this. and it looks good. Okay, I hope all of you understood, and thank you for watching.